All right, let's,
It's 166.
in your notes, where you have put your derivative rules. Now, at some point, we're going to recopy these derivative rules, actually probably starting tomorrow. We've got another thing to learn tomorrow about these, but for now, you can add to those, or you can, since we're going to probably rewrite our derivative rules anyway, if you want to put these in the new, in the new place in your notes, is probably good. Because that's our focus on our homework will be these. But for sure, those rules we've had so far, we need to be able to do. Now, judging from the quiz, we've certainly got some practice to do on those. And that's what Chapter 3 is, actually. Chapter 3 is, all right, let's take those, the power rules, sine. We know the basic rules for sine, cosine, natural log, e to the x, those. Now let's go through all the possible different variations of that. What are all the different things that could happen with equations and functions, and how do we do their derivative? All right, so that's what Chapter 3 is. So this will be, rarely will we use the calculator here in Chapter 3, other than to kind of check our work when we do our derivatives, like I talked about in the electronic solutions manual. Our next quiz, and we're going to do it a little differently this year. It's essentially going to be the same for most of you. But it's called the gateway test. Now, in the past, what I've said is everybody will pass the gateway test with an 80% or better. Get 10 questions, like problems 5, 6, 7, and 8, where, although these are all derivatives, no antiderivatives. Okay, everything now, this chapter is pretty much all just derivatives. Okay? 10 questions, here's y equals this, you do the derivative. And in the past I've said everybody has to get 8 out of 10. You have to keep taking one until you get 8 out of 10. Your grade in the grade book is based on how long it takes you to pass it. So most of that I'm going to keep the same. What I found was there were people who gave up after several tries, never came in, they ended up with a 0. That didn't used to happen, but the last couple of years there's been a disturbing trend. I don't know what's the problem. But so this could be a real opportunity depending on how hard you want to work at it. If you get 8 out of 10, 9 out of 10, or 10 out of 10 on the first try, there's no partial credit, it's got to be right, then you get a 30 out of 30 in the grade. Awesome. Okay, for a quiz grade. You may then, and I'll have, well, if you don't get 8 out of 10, then you could just take whatever grade you get. So if you get 7 out of 10, you get a 21 out of 30, that's 70%. If you get 6 out of 10, you get 18 out of 30, that's 60%. Okay, if you get 2 out of 10, which there almost always is somebody, seems like, you can get a 20, you can get a 6 out of 30 in the grade book. And you can take that grade. Now, I've never let people in the past do that, but then I end up fighting about getting them in and when they can come take them, whatever. So at this point I'm saying, hey, if you want to take a 6 out of 30, take a 6 out of 30. Okay? But you can, if you do not get 8 out of 10, you can come in outside of class time and take another one. If you pass the next one, and I may even give you 2 more tries after the first one to get 8 out of 10. And if you get 8 out of 10 on one of those 2 tries, you get 28 out of 30 in the grade book. See how this is going?
Nice.
And if you don't get it on those, you can try a couple more times, and then it drops down to like 26 out of 30. Okay? And so forth. Now at that point, we're going to kind of run out of time because we're bumping up against Christmas here for this term anyway. And then we'll talk about what we'll do if you haven't passed it yet, what grade's going to go in the grade book, and so forth. Typically, it comes down to if you're going to drop the class and you're not going to be here after Christmas, then you have to take whatever your best grade is, essentially. But if you're going to be here after Christmas, you want to keep taking some to try to get that better grade, I can do that, and then I can retroactively come back and put it into this term. Okay? All right. So, that's our next quiz. That's basically the only quiz we will take in chapter 3. Okay, that's the only quiz we'll do in chapter 3. Will be that. All right, so here we go. We have 2 rules to do today. 2 new derivative rules. The first one is called the product rule. Gee, just happened there. All right. Now, here's what the product rule says. If you are going to do the derivative of 2 functions multiplied together, right? F of x times g of x. Now, sometimes, and we'll write this, this will be one that we'll actually memorize later. A lot of times, just so we don't get all caught up with that f of x and all the parentheses and notation and everything, the tradition has kind of been to use u and v to stand for functions of x. Think of it as u of x and v of x, but we just say u and v. I'm going to multiply 2 functions together. Now, and you can do this with me on your calculator if you want, because we know the calculator will do derivatives for us. So one thing we might do is just let's do one and let's see what the calculator says. So if I come in here and put an x in, derivative with respect to x, and let's try a real simple one here. Let's put x squared gotta hit my right arrow times sine x. Okay? That's 2 functions multiplied together. Now, we have not learned anything that would allow us to do that. Now, you probably hit in already. But if things were going to be easy, this answer would be what?
X squared.
2x cosine x, right? If life was going to be good, it would be 2x cosine x. We just do the derivative of each one individually. Because we do that with plus. Now think about that. Plus and minus, we do that. If I got x squared plus 3x, I do the derivative of x squared is 2x plus the derivative of 3x, which is 3, and that's very nice. So if I'm adding or subtracting functions, I can just do each individual derivative. It'd be nice with multiplication if we could do that, but we can't. So we need something called the product rule. So you hit enter and you saw this. So now look carefully at it, what's it look like they did?
Well, they took x squared and kept that, and then sine x, and they kept that. So they took this.
They took turns, right? They took turns. They said, hey, you go first. Well, actually, I'll be honest, I normally write this differently. They like to write the highest power first. Normally this rule is written, it's like, you go first. Do that derivative, 2x, we'll leave that alone. Right, 2x sine x, plus, then we'll leave this one alone, and then we'll do that derivative, right? And that's exactly what the rule says. So when we write it, since the one that comes first, right, we'll do that derivative first. So we'll say f prime, it doesn't matter, because there's a plus sign in between them, so it really doesn't matter which we do. But you'll see on our second rule why it matters, so it's a good habit to be into. So we write it just like this. Right? It's f prime times g plus f times g prime. Or if we're using uv, and this is the one we'll reference most of the time in class, it'd be u prime v minus uv, plus, not minus, u prime v plus uv prime. So the product rule is very simple in that form. Now obviously it's going to get more complex as our functions get more complicated. But that's the product rule. All right. Second, makes sense. The next one would be the quotient rule. Whoops. Quotient rule. Now, on the quotient rule, we're not going to even do it on a calculator because it writes in a weird kind of way. It's hard to really see where it gets that from. And later, after tomorrow, we'll talk about how you really wouldn't need a quotient rule because every quotient you can do is a multiply by the reciprocal, right? You can turn every quotient into a product and just do that. But actually, that gets more complex for a lot of them. So we're better off having a separate rule. And the rule says this, and I'm just going to write this one with U's and V's just for time. Okay? If you've got a function divided by another function, then the rule is this. And this is where it's nice to write the product rule this way. We do the derivative of the top, u prime, times a v left alone, but this time it's minus, and therefore we have to have it in the right order. And then uv prime. So the top looks just like the product rule if we write it that way. And just think of it, hey, the first one in line gets to do the derivative first. The top one gets priority over the bottom one. It will do it first. So, and then all over the bottom square. Not the derivative of the bottom, just the bottom square. So again, we take turns in this order with a minus in between, and then over the bottom square. That's what the derivative looks like. So, for a few examples. We just did an example of a product rule. So let's say I had y is equal to x squared over sine x. Right? That was, now, just like when we first learned our rules that we already learned till today, if you could do some algebra simplifying or some trig substituting or something, that's great. Go ahead and do that first. Okay? But there's nothing we can do to this. So especially when you're mixing different function families together, there's usually not a lot of simplifying that can happen. So y prime would be what? Tell me what to write. 2x times sine x minus
x squared
cosine x all over sine squared. Right?
Yep.
That is it. Now, you might say, hey, we can factor an x out of the top, but if you do, then there should probably be something in the bottom to cancel it with, and there's not. So I wouldn't do that. If there was something down here, then yes, I would say it'd be okay to go ahead and factor out an x, okay, to cancel and reduce, because we do want to simplify. I picked a pretty nice one. It didn't have any negatives in its exponents or anything. But you can see where it get a little more complex if one of those was, say, 5 to the x, right? You got to tack on the ln 5, you got to remember that, right? So you got to remember all those rules we had before. But if you have a product or a quotient, we do this. Okay? All right. Now, on your homework, on page 166, it talks about doing these derivatives 2 different ways. Okay? For example, this is one of your homework problems right here, number 13. This is page 166. Number 13 says h of x equals e to the x times e to the 2x. Right? Now the directions say to do it 2 ways. Use the product rule and by multiplying it out first. And then the next section says by dividing it or simplifying first. So in other words, on the first set of exercises, they're going to give you ones that you could do some algebra simplifying first. Now, a few people came and asked me during the quiz on that last problem we had all those x to the 4th and x to the 6th and stuff. Some people said, should I factor out an x to the 4th first before I do the derivative? Well, the answer to that was no. Because what happens if I factor out something first, now I've got a product, right? And yesterday we didn't know the product rule. So you don't want to turn it into a product and have to do the product rule if you weren't going to have to before, right? The whole point of simplifying it here first is to make it easier, not to make it harder. Okay? So in this case, let's pretend we didn't see the algebra that we could do. And so we said, hey, here's a product rule. It's a u and a v right there. Correct? So the product rule would tell us that h prime is what? U prime, which would be e to the x, e to the 2x left alone, plus, and this is a weird one because when you do the derivative of e to the x, it's like you're leaving it alone, so it seems strange. So we leave the e to the x alone, and that's 2 e to the 2x. Now we're really going to have to be careful with our algebra as we do these, like putting negative signs in the right places. And where do we write the 2? We would normally never write the 2 here, right? We would write it out in front. Now, at this point, then all of a sudden it might dawn on us that, hey, e to the x times e to the 2x is what? That's e to the 3x. So this is e to the 3x plus 2e to the 3x, which of course would be 3e to the 3x. And so by doing the product rule, we get that. Well, we'd have been much smarter, and here's what they want you to do now in 13 as well, is if we'd have went ahead and done that first, we'd have got what? Am I still on the board?
Yep,
I'm not-
Barely.
H of x would be e to the 3x. So therefore, h prime of x, you kick out a 3, you get 3e to the 3x. Now it is kind of nice to know that the product rule does seem to work in that case too. And, right, you'll sleep better tonight knowing that, hey, it worked on that one. Okay? So, so this would be one, if we came across this, we'd have been much better off simplifying it first and then doing the derivative rather than doing the product rule. It was just longer. But they've got a few examples they want you to go through and just see that and practice that. Okay, last comment I want to make, and this is on page 167. I want us to look at problem 59. Problem 55 on page 167. Now this one's not in your homework, but you're going to have some like this in your homework. 55, if you look up in the directions, they tell you that g of x is equal to sine of x times f of x. Now, that's two functions multiplied together, right? One of them we don't know much about, other than the graph they tell us is what? They tell us the graph there is f prime. So that graph we have is f prime. So we got some sine x times some unknown function f. 55 says, is g increasing at pi halves? This is kind of a way to see, do we really understand the old chart now? What's it mean for g to be increasing? G prime has to be positive. So what we're looking for here is g prime. I'm going to leave myself a little gap there. I need to know what g prime of pi halves is. That's what I need to know. What is g prime of pi halves? Is it positive? Then g is increasing. Well, before I can do g prime of pi halves, I need a place to plug the pi halves. I need g prime of x. So g prime of x, since this is a product, I'll have to do the product rule, right? So what's the product rule say the derivative will be? Cosine of x times f of x left alone plus sine of x times the derivative of f, which is f prime of x. Take turns. Product rule. Now, how do I find g prime of pi halves? I plug a pi halves everywhere. Now, most of this is going to be pretty easy. Cosine of pi halves is what? Cosine of pi halves. Pi halves is 90 degrees, x-coordinate, unit circle, whatever, 0. So that's great. That wipes that all out, right?
Yeah.
So that'll be 0 plus, what's sine of pi halves? 1 times f prime of pi halves. Well, how can I find f prime of pi halves? Look at the graph. The f prime graph is right there. Pi halves is where? What's pi halves as a decimal? 1.57 roughly. So you come over here to 1.57, what do you notice on the f prime graph?
It looks like a method.
But, do we care? What do we want to know? About all we really care about, because this is 0 and that's 1, all we really care is a positive. And it definitely is. It looks like it had, and actually all we care, we were looking at the y value, right? Everybody clear on that? We were looking at the y value of this graph. and its y value is up there around 3 something. So clearly, g prime is positive, so therefore the answer to the question is g is increasing. Really good question because it makes you think of the chart. You have to use your product rule here. Think about that. Plug in a pi halves, get a value to answer that question. So you do have a few in there that do that. So most of the homework is simply practice following these two rules, either the product rule or the quotient rule. And then there's a few that get into this kind of plugging in kind of thing along with it. All right, so your assignment's the first line on that homework sheet. Okay, product rule and quotient rule. Again, really work hard on these rules because this is an opportunity. If you pass that quiz the first time, it's 30 out of 30. And all you have to get is 8 out of 10. That doesn't sound like much, but
What?
it takes some work to get 8 out of 10.
Like, are they like really complicated?
They go from
You're excited.
kind of a mixture of easy to medium to hard.
Yeah.
Like 3, 3, 3, something like that. In other words, to get 8 out of 10, you probably better be able to do some of the hard ones. Okay? Now, traditionally, 25 to 30% have passed the first time, but almost everybody who really works at it can pass by the third attempt. And that's a 28 out of 30. Okay? So, to pass on the first attempt has usually been difficult, but it seems like if you really work at it,
Is it like problems that are just like
they're very straightforward, absolutely. And I'll show you some websites, well, hopefully we can find someone that practice those kind of problems.
My phone is indestructible. I went to work.